Hello, welcome to my recorded classes. So, this recorded class we are discussing a topic from discrete mathematics or discrete structure uh, from module 5 advanced topics in graph theory, section number 5.6 minimum spanning trees. Okay, so let's start the content here. So, in module 5 advanced topics in graph theory, this is the section number 5.6 minimum spanning trees. Okay, so let's start the content. So before starting minimum spanning tree, okay, the recorded class 5.5 section already we are discussed what is the meaning of spanning tree, correct? Now here we are discussing how to find the minimum spanning trees. So spanning trees means what is the meaning? Spanning tree of a graph G is a subgraph of G that contains every vertex of G and it is a tree. That is the meaning of spanning tree, correct? Spanning tree means from a graph when we are finding spanning tree, it should have all the vertices and it should be a tree, correct? That means it should be connected, should not have simple circuit, correct? And every vertex should be there. So like that spanning tree we are forming. Out of these spanning trees, we already studied the Kirchhoff matrix, how to find the number of spanning trees, correct? So out of the spanning tree, which is the minimum spanning tree? That is the question here we are doing in 5.6 section, minimum spanning trees. So before coming to this point, minimum spanning trees, we will discuss what is the meaning of weighted graph. Okay, so you can see weighted graph. A weighted graph means is a graph for which each edge has associated with a real number weight. Okay, in simple way, in a graph each edges, okay, we have assigned one weight. For example, see in this graph, here one graph is given, graph G. Each edge we can see one weight is assigned. For example, from this vertex, what is the weight? 3, correct? 3 is the weight. Same like all the edges, we are assigned a weight x. It may be distance or something else, okay? It is assigned one number here. That number is calling the weight of that edge. Same like all the edges, we are assigned one weight is here. Now the sum of the weight of all edges is called the total weight of the graph. Okay, so weighted graph means each edge we have a weight. Now sum of the weight of all edges we are calling total weight of the graph. Okay, so for example this graph G, what is the, find the total weight of the graph from the given figure. Example number 1, you can see, find the total weight of the graph given in the figure. So we will see total weight equal to each weight we can add. Okay, whatever the edge given, whatever the weight assigned there, add all the weight. So here 2 plus 6 plus 3 plus 2 plus 3 plus 1. Okay, all the weight we are adding. So we will get totally equal to 17. This is the total weight. Okay, total weight of that graph G. Okay. Hope you understood what is the meaning weighted graph and sum of the weight, how to calculate the total weight of the graph. Okay, so weight may be anything. Sometimes the distance between two vertices, for example this vertex and this vertex, what is the distance, we can assign that one. Okay, distance between two cities, like that we can assign the weight there. Okay, now let me go to minimum spanning tree. What is the meaning of minimum spanning tree? Okay, so if G is a connected weighted graph, spanning tree of graph with the smallest total weight is called the minimum spanning tree of the graph. For example, when we are considering a graph, we have many spanning trees, correct? Out of this all spanning tree, which spanning tree getting minimum weight, total weight, some smallest total weight, that is what we are calling the minimum spanning tree. For example, see this graph we are discussed in the 5.5 section also. When we are discussing the spanning tree, that time we discussed this graph. You can see this graph G. Okay, A, B, C, that are the vertex. 1, 2, 3, that are the weight assigned to each edges. Now just calculated what are the spanning trees here first. See T1, T2, T3. T1 first spanning tree, T2 is the second spanning tree, T3 is the third spanning tree. We studied how many edges we need to remove for getting a spanning tree, correct? M minus n plus 1. M is the number of edges. Here we have 3 edges. Minus n is the number of vertices. We have 3 vertices plus 1. So equal to 1. 3 minus 3 plus 1 means 1. One edge if you are removing, we will get a spanning trees. So one edge we are removing from this graph, we are getting 3 spanning trees like this, T1, T2 and T3. Now out of these 3 spanning trees, calculate the total weight each spanning tree. For example, first spanning tree 1 plus 2, that is 3. Weight of that spanning tree is 3. Second spanning tree weight equal to 4. Third spanning tree weight equal to 5. 3 plus 2, correct? 5. Now out of this one, which is the minimum weight or smallest total weight? Here it is 3, here 4 and here 5, correct? So this is the smallest one. Smallest out of all spanning trees, which is the smallest total weight getting, that is the minimum spanning tree. So which is the minimum spanning tree here? T1. This T1 graph is the T1 tree is the minimum spanning tree. We can call it as minimum spanning tree. So that word meaning it is clear. Minimum means smallest total weight out of all spanning trees. Hope you understood. Now if G is a weighted graph and E is the edge of the graph, weight of an edge we are representing W of E, weight of that edge, whatever the edge, weight of E, and weight of the graph, total graph we are representing W of G. W means weight of the graph G. W of E means weight of that corresponding edge, okay, corresponding edge weight, W of E. W of G means total weight of the graph. For example, here AB, what is the weight? AB edge 1. So weight of the edge A comma B means it is equal to 1. Total weight means complete weight we are adding. Each edge's weight we are adding, we will get a number, that is the weight of the graph, weight of the edge and weight of the graph, okay, representing like this. Okay, now we need to calculate what is the minimum spanning tree. Okay, here simple example, the small graph we can get it, this is the minimum spanning tree. Same if you are getting any graph, how to draw a minimum spanning tree or how to calculate a minimum spanning tree or weight of the minimum spanning tree. For that we are using one algorithm, that is we are calling Kruskal's algorithm. So how to calculate, how to get minimum spanning tree by using Kruskal's algorithm. This is what we are main idea, this section, Kruskal's algorithm. And another one, Prime's algorithm is there, okay, that will upload in the next recorded class. This recorded class we are discussing Kruskal's algorithm. So how to calculate minimum spanning tree by using Kruskal's algorithm. So Kruskal algorithm, what we are getting? We are getting a weighted graph, connected weighted graph as the input. We need to calculate what is output we needed. Output needed is minimal spanning tree, correct? You can represent MST. MST means minimal spanning tree, MST, short notation, okay? When we are writing MST, we can write minimal spanning tree. So output we need minimal spanning tree, okay? We are giving a graph, we need minimal spanning tree and weight of the minimal spanning tree. So these are the steps we need to do, step 1, step 2, step 3 and step 4. In step 1, what we are doing is the edges of the graph arranged in order of a increasing weight. Okay, first write smaller weight, then next bigger, like increasing weight. Okay, we are arranging the edges by increasing weight. After that, an edge with minimum weight is selected and as an edge of the required spanning tree. Edge of the minimum weight select and add to the minimum spanning tree. When you are doing the question, you will get that one. Now, after that in step 3, edges with minimum weight that does not form a circuit with already selected edges are successively added. This procedure will be repeated after n-1 edges have been selected. These are the 4 steps. Let me see these 4 steps how we are doing in the question. Okay. For example, this example you can see, example number 3. Use Kruskal's algorithm. Find the minimal spanning tree for a graph G. See, one graph G is given here. Okay. Graph G is given. How many vertices are there in the graph? 6 vertices. Okay, 6 vertices. Now this algorithm, we have one stopping condition is there in the algorithm. When we are stopping the algorithm, the procedure will stop after n-1 edges are selected. N- edges selected means, already selected means this algorithm will stop. N means number of vertices. Number of vertices minus 1 edges have been selected. For example, this question, how many vertices are there? N value equal to 6. Correct? So n-1 means 5. 6 minus 1, that is 5. So how many edges we should be added into the minimal spanning tree? 5 edges should be 5 edges, n minus 1 edges have been added, means that algorithm will stop. Okay, so first check this number, how many vertices are there in the graph. That number of vertices minus 1, that is n minus 1. That many edges when we are added to the spanning tree, we can stop that algorithm. That is the stopping condition. Okay, anyway, we'll start. What is the first step we need to do? Edges of the graph arranged in the order of increasing weight. So each edges, you can see the graph. What are the weight of the each of the edges? So you have minimum is 5. Okay, starting 5, then 6 is there. Okay, after 6, 10 is there, 11 is there. Okay, so what we do is we are doing this question by using a table like this. First we need to write the weight. What are the weights? Okay, I can see here. How to do this question? So first step we need to write the weight of the graph in increasing order. Okay, that keep in our mind which order we need to write. Increasing order. Okay, we need to write the weight of the graph in increasing order. So as I told you, what is the minimum weight here? 5, then 6, then 10, correct, then 11, like that we need to write one by one. So 5, 6, 10, I can write 5, 6, 10, 11, then which is the next weight, smallest, 14, 16, 18, 14, 16, 18, already answer is here, just showing the steps, 19, 21 and 33, 19, 21 and 33. Okay, now what are the edges? Okay, write here what are the edges representing this weight. You can write here one by one. Okay, you can see, for example, 5 weight. What is the edges? The edges 5 weight, B and F. This edge, correct? B, F. So we can write B, F here. The set bracket we need to use because it is undirected graph. B, F. F and B we can write any order. If you want FB, that also fine. Okay, undirected graph. So FB, what is that edge? 5 weight representing edge is BF. Now 6 means this one, BD or DB. We can write BD or DB. So I can write that one here, 6. Now 10 means, you can see 10 means DF. I am writing set notation DF. Okay, then 11 means EB, this one we can write here EB. Then ED, 14 means ED, this one, correct, this edge name. Okay, then 16 AB, 16 means AB, this one, and 18 CD, that is 18, AC, that is 19 here, and AE, that is 21, AE, that is 21, and CE, that is 33. So all the edges we are written here in the increasing order of the weight. Okay, first smallest weight, then increase, last bigger weight, like, okay, that is the increasing order. So this is the first step we need to do in the algorithm. Hope you understood the first step. Write the weights, okay, edges weight in the increasing order. Okay, so you can see the algorithm now. So step 1, I hope it is clear to you. Write the edges weight in increasing order and write the edges name also using the set bracket. Don't forget, because it is undirected graph. Undirected graph we are using set notation. Inside we can write the edge starting and ending point. There is no starting and ending because it is undirected graph. So any order you can write inside. Now step 2. Now we are starting to form the minimum spanning tree. Okay, we are starting to form the minimum spanning tree. So third column, added in minimum spanning tree or not. That means this edge, first edge, added in minimum spanning tree or not. That is the question. Okay, so what we need to do for that is, I can show here how we are doing that one. For example, first I am marking what are the vertices? A, B, C, D, E, F. See, I am just marking this is A, B, C, D, E and F. Only one vertex, all vertices, okay? All vertices just to draw, because spanning tree should contain all the vertices, okay? So just to draw all the vertices, the same graph, all the vertices, A, B, C, D, E, F, same order is better. Now, first one, BF. BF edge is the minimum weight. Start with the minimum weight. This edge first add to the minimum spanning tree or not? Yes, we need to add BF. Okay, so BF, what edge I am added? BF edge. This edge I am added. What is the weight of that edge? 5. I can mark here 5. Okay, so this is added or not is the question. Yes, it is added. How we are writing yes or no? What is the condition? It should not form any simple circuit. That is the idea. Simple circuit should not form. So we will continue. See, BD, next number is 6. Next smallest weight we can add 6. BD is the edge. Can we add to the minimum spanning tree or not? Yes, BD. So I can see B and D. See, I am added here. What is the weight of that? 6. So I can write here 6. Now add like this, it should not form any circuit. That only the condition, simple circuit. Now next one, 10. Can we add this 10? DF, can we add DF? We will check here. D and F. Can we add D and F? You cannot add this one, correct? Because it is forming a circuit. Circuit means it is a triangle like this. The triangle or starting and ending point, we can reach same point like this, means it is a circuit, simple circuit. Okay. For example, here see, if you are starting with B, you can move like this, you can move like this, you can reach same point B. It's a simple circuit, correct? So it should not be, that edge should not be added to the minimum spanning tree. Okay. So I am writing here no. See, I wrote here no, because that edge, if you are adding, a circuit is forming. What circuit is forming? If you want, you can write the last. This last column is not mandatory. That is for just understanding. Okay. So which circuit is formed? FBDB. Sorry, FBDF. See, FBDF. See, one circuit is forming. So that we cannot add that one. So that edge is not added. Okay, hope you understood that idea. Now like this we are continuing. Now next EB. Can we add EB? 11 weight. We will check that one. EB. Where is EB? That is EB. So this is okay. There is no circuit forming. Correct. So what is that weight? 11. 11 is the weight. So EB we are added because there is no circuit is forming. Like that, how many edges we need to add? 5 edges. Once you reach 5 edges, we need to stop that one algorithm. Okay. So 5. So next one, ED. Can you add ED with 14? ED. ED, if you are adding, what happened? E and D. See, this we cannot add. It will form a circuit again. See, one circuit is forming. So that we cannot add. ED is not possible. It is forming a circuit. So we will go next one. So this one is no. Correct. Now AB, can we add AB? 16 weight. We will check that one. AB. AB adding no problem. 16 weight we can add because it will not be any circuit. Correct. So it is correct. No problem. Yes, it is. We can add. Now CD, 18 weight. Can we add or not? We will check this one. CD. CD we can add. There is no circuit here. Correct. So 18 weight we can add. It is not forming any circuit. Okay, so it is yes. Now already how many we are added now? 1, 2, 3, 4, 5. Once we added 5, the algorithm will exit. Correct. This is the stopping condition. Stopping condition. Now remaining, what we can do? AC, it is no. AE no. CE no. You can check also one time AC. For example, if you are adding AC, what happened? You can see. AC if you are adding here, it will form a circuit. See one circuit is here. This will form a circuit. Starting and ending point will be same. Correct. So AC we cannot add that one. Same way another edge also. AE also we cannot add AE. For example, AE. What is AE? This is AE. If you are adding again here, one circuit will form. Correct. So that also not possible. Now CE also not possible. If we add CE, see it will form a circuit again here. So already we are added 5 edges, n minus 1 edges means we can stop the algorithm. So we will get a spanning tree is there. This is we are calling the minimum. This one we are calling minimum spanning tree. Okay, this is we are calling minimum spanning tree. This algorithm we are calling Kruskal's algorithm. So what we did in the minimum spanning tree, we got like this one, correct? Minimum spanning tree, it must include all the vertices. All the vertices should have, correct? And some edges all connected, all vertices should be connected. See, all it is connected. Some of the edges we cannot add because it will form a simple circuit. So this is the minimum spanning tree by using Kruskal's algorithm. Now we need to calculate weight of the minimum spanning tree. What is the weight of the minimum spanning tree? Just add these numbers: 5 plus 6 plus 11 plus 16 plus 18. We will get a total weight equal to 56. That is the weight of the minimum spanning tree. So Kruskal's algorithm, you understood, I hope. Kruskal's algorithm, we need to draw minimum spanning tree, correct? What is the minimum, how to calculate minimum spanning tree, and what is the weight of the minimum spanning tree? Weight of the minimal spanning tree. Okay, these two we need to check by using Kruskal's algorithm. Hope you understood this algorithm. Okay, how to check the minimal spanning tree and how to calculate the weight of the minimal spanning tree. Okay, now let me go to the exercise 5.6. First question, find the total weight of the given graph. Total weight, only we need to just calculate what is the total weight of the graph given here in the question. What is the total weight? So weight of the graph G we need to calculate. What we need to do? Just add all the weight here one by one. So here 4 plus this 4 plus 2 plus 2 plus 3 plus 4 plus 3 plus 3, correct? So totally we will get 25. Weight of total weight equal to 25. You can check by calculator that number, correct or not. Okay, now B part. We need to calculate what is the total weight of the graph. Weight of this graph equal to, same way we can add the numbers. So 7 plus 9 plus 3 plus 7 plus 12 plus 5, correct? Totally we will get equal to 43 total weight. So total weight calculation is easy. Just calculate the total weight assigned to each edges, add these numbers, we will get total weight. Hope you understood now. Now we will go to the main idea. Use the Kruskal's algorithm to find the minimal spanning tree for the given graph G. Use Kruskal's algorithm to find the minimal spanning tree for the given graph G. See, one graph is given here. This is the graph G. So check how many number of vertices. Number of vertices of the graph equal n equals. Number of vertices n equal 1, 2, 3, 4 and 5. We have 5 vertices. Now number of edges, number of edges no needed here. Number of vertices equal to 5, correct? So n minus 1, just to check what is n minus 1. N minus 1 means 5 minus 1, that is equal to 4, correct? So this is the stopping condition. How many edges we need to add here? 4 edges, correct? Stopping. Stopping condition, Once you added 4 edges in the minimal spanning tree, you can stop the algorithm. You can calculate what is the weight of the minimal spanning tree by using Kruskal's algorithm. Okay, so let me go to the question here. So this is the graph G. Okay, so first step one we need to do, we need to write the weight in increasing order, correct? What is the minimal weight? First check it. 1 here, 1 here. So I can add 1 and 1, correct? Now what is the next number? 2 is there. Here 2, here 2. So we have 2 and 2. Then 3 and 3 and 3. We have 3 times 3 coming. Now we have 4 also. This 4. So I can write here 4. So write the weight in the increasing order, first step. Okay. Now we need to go to the minimal spanning tree. Now each edges one weight. What is that edge? We can write here. One weight means the edge is AB. One edge is AB. So we can write set notation AB because undirected graph. And CD, C comma D. You can write DC also, no problem. Now number 2. This is number 2. Number 2 means there are 2 AE and ED, correct? AE and ED. Number 3, we have 3 edges are there. One is this, one is this, and one is this. You can write any order, no problem. So first E, B, then CE, then we have BD, correct? Now 4, what is the 4? This one, AC, AC. Okay, so every edges we are marked in the increasing order in the table. Now we are starting the minimal spanning tree creation, constructing. Okay, so first draw all the vertices here. This is A, this is B, okay, C, D, and this is E. Okay, only draw all the vertices. Now we need to add the edges one by one by using Kruskal's algorithm. So we will check the Kruskal's algorithm. What is the minimal weight? First 1. Added in MST or not? MST means minimum spanning tree or not? Yes, we can add the first one. What is the first one? AB. AB I am added here. What is the weight of that one? 1. Okay. Only we need to think the circuit is forming or not. Simple circuit, if you are forming, if it is forming, we cannot add. Now CD, can we add CD? CD, you can check it, C and D. Yeah, we can add because there is no circuit forming. So S, what is the weight? 1. We can write 1 here. So this also finished. Now AE, AE is 2. A to E, one edge is there. Can we add? S, there is no circuit forming. So we can write S. What is the weight of that one? 2. We can write 2 here. Okay, how many edges we need to add? We are written here the stopping condition, 4 edges, correct? 4 edges added means it will stop the algorithm. Okay, now ED, ED is 2. Can we add or not? ED edge, ED. Yes, don't have any problem, no circuit forming. Yes, we can add, correct? There is no circuit forming. Circuit means starting and ending should be same. Okay, should be travel to all vertices edges like. Okay, we can check that one, circuit forming or not. Okay, so it is added. So already 4 edges added. So algorithm is stopped. Now we will check another edges. What happened? Can we add this EB? What happened? EB adding EB. This edge can be added? Cannot add because if you are adding, it will be a circuit. See, for example, if we starting B, B to A to E, then again we can reach the same point. This is the meaning circuit, symbol circuit, correct? So we cannot add that edge. So this is not possible. No. Now if we are adding CE, any circuit forming? Yes, this is also will form circuit. See here one circuit will form. So that also not possible. So we can write no. BD if you are adding time also circuit will form. This is BD. So here see starting and ending should be same. One circuit will be there. So we cannot add that also. No. And AC also same. This is AC. One circuit will form like this. That also not possible. Okay. So already 4 added. Now what is ED? Wait, we need to write here. ED is 2. Correct. Now, so this is the minimal spanning tree. Okay. So this is the answer. Minimal spanning tree. Now we need to calculate what is the weight of the minimal spanning tree. Weight of the minimal spanning tree by using Kruskal's algorithm equal. Add this weight. What are the weight we are assigned here? 1 plus 2 plus 2 plus 1. So how much we are getting totally? Total weight equal to spanning tree weight of the minimal spanning tree equal to 6. 6 is the weight of the minimal spanning tree. I hope it is easy. Okay, hope you understood that one, this idea. One more question we will practice here. Question number 2b part. Use Kruskal's algorithm. Find the minimal spanning tree from the graph G. Correct? Find the minimal spanning tree by using Kruskal's algorithm. Okay. So first we to check the stopping condition. How many vertices are there? Number of vertices equals 1, 2, 3, 4, 5. Correct? So calculate n minus 1. N minus 1 equal to 5 minus 1, that is equal to 4. So how many edges we needed in minimal spanning tree? 4 edges. Correct? Only 4 edges. After 4 edges, the algorithm will stop. This is the stopping condition. Okay. Stop algorithm once we added 4 edges. Okay. Okay. So we will start this question. You can see. So first write the weights in increasing order. Correct. Write the weight in the increasing order. Increasing means first small element, then higher elements like. So which is the smallest one here? 3. You can see 3. Correct? 3 means what is that edge actually? BE. I can write BE. Now which is the next one? 4. Here 4 is there. What is 4 actually? GE. Correct? The edge GE. That is 4. After 4, what is the next one? 6. Here 6. Correct? BG. So I can write BG with 6. Now after 6, which is the next one? 7. Here EF. Correct? So EF is 7. Now after 7, we have 8 here. What is that 8? DF or FD. Okay. So we can write DF. That edge is DF. That is 8. Now after 8, 9 is there. Here that is DG. DG 9. Correct. Now after 9, again one more 9 is there. What is that? This one. BE. Correct. One more 9 is there. After DG, that is next. Sorry, not that 9. Next 9 here. DE. So I can write D and E. 9. So that also done. Now next one 13. This one. That is this one. B and F. BF, that is 13. Now after 13, we have 16 BD, correct? 16. Now after 16, 20 is there here, GF 20. Hope you understood how we are writing in the first step. Write the weight in decreasing order. Write the name of the corresponding edges here in the first column. Now here we will form first, draw all the vertices, correct? So this is D, this is E, then we have B, then we have F, then we have G. Okay, D, E, B, F and G. Right, draw all the vertices. Okay, now we are starting to add the edges to the minimum spanning tree. So first take the minimum weight, that is 3. Can we add 3 to the minimum spanning tree? BE, that is BE, correct? So I am drawing BE. No problem, we can add. Weight is 3. So yes. Like that, how many edges we need to add? 4 edges, okay? We need to add like 4 edges without symbol circuit, okay? Now next one 4. What is that? GE. Can we add GE? Yes, no problem. GE we can add. Yes. What is the weight of that one? 4. Now the next one. Okay, next one, that is 6. BG. Can we add BG? This one we cannot add. So it will form a circuit here. See, it will form a circuit. Starting and ending should be same. We will get a path. So we don't want that one, correct? So no. Now the next one. Can we add this 7? EF. EF, no problem. There is no circuit. We can add that 7, correct? So yes. Next DF. Can we add DF or no? We can check it. D and F. DF we can add, correct? Yeah, there is no circuit there, so we can add D and F. See here, there is no circuit, correct? So yes, that is 8. That weight is 8. Okay, here there is no circuit because don't confuse here. There is no vertex here and here. If it is here only, that circuit will come, correct? So just crossing that line only, there is no vertex there, so there is no circuit. Symbol circuit is there, not there. So already we are added 4. 1, 2, 3, 4. Okay, now we are checking other one. Is it possible or not? Like now this 9. DG can we add? DG. DG we cannot add. If we are adding this one, it will form a circuit here. See, if we are starting this one, ending this one, ending this one, and see, it will form the same point. So it is a circuit. Cannot add that one. Okay. Now same we can check. So this is no. 9 can DE, can we add DE? No. This is also will form a triangle like a circuit, symbol circuit. So no. BF. BF also it is not possible because it will form a circuit, symbol circuit. So no. 16 BD. BD also it will form a circuit. So no. GF 20. GF, this is also will form a circuit. So it is no, correct? So this is the minimal spanning tree from that graph. This is the minimal spanning tree. Okay, now once we need to calculate what is the weight of the minimal spanning tree. Weight of the minimal spanning tree equal, just add the weight here 3, 8, 4 and 7, correct? So 3 plus 4 plus 7 plus 8. You will get the number equal to 22. That is the weight of the minimal spanning tree. So we got the spanning tree and minimal spanning tree by using Kruskal's algorithm. Hope you understood this question. It is easy to practice. You have some question here for practice. Some graphs are given, you can check it what is the answer you are getting. So this section we are studied how to calculate the total weight of a graph. Okay, how to calculate we studied, and we studied the Kruskal's algorithm to find the minimal spanning tree, how to find the minimal spanning tree by Kruskal's algorithm, and how to find the weight of the minimal spanning tree by from that spanning tree, minimal spanning tree, how to check this one. So these two we studied this section. I hope you understood that one. Thank you for watching this recorded class. Please subscribe my channel for getting more recorded classes. Thank you very much.